Hey, hello students. Let's revise today modulus function. So I'm just starting the basics from the modulus function. What do you mean by modulus function? See, now I'm going to explain this concept with the help of number line. So let us plot the number line. So this is the number line from minus infinity to plus infinity. So these are the numbers 0, 1, 2, 3, 4. Then we have minus 1, minus 2, minus 3, and so on. Now suppose if my question is how you will find the distance of the point from the origin. Suppose my reference point is this origin. Now what is the distance of 2 from 0? Now how will measure it? It is 1 unit, then 2 unit. Now again if I ask you what is the distance of minus 2 from 0? Now see again 1 unit, 2 unit. So in both the cases the distance is 2. And everybody know that the distance is a non-negative quantity. Distance is a non-negative quantity. Now what do you mean by non-negative? Whenever I am using the word non-negative, certainly its meaning is greater than or equal to 0. So now this motivates us to define a new concept. So how we define? If x is any real number, then its modulus is denoted by this symbol, mod x, or sometimes we call this as absolute value of x. Now geometrically this mod x is nothing but distance of x from origin, that is from origin. So now suppose if I ask you what is modulus of 3, so it means you are measuring the distance of this 3 from the origin. So certainly it is 1 unit, 2 unit and 3 unit. Again if I ask you what is the modulus of minus 2, it means you are measuring the distance of the point minus 2 from the origin, that is 1 unit and 2 unit. Again if you are writing here modulus of 2, so what is that? Distance of 2 from the origin. Now what do you see in that? That whatever input I am giving, I am getting a non-negative number. So from this, can I conclude that mod x is always greater than or equal to 0? Always means for all x belongs to the real number. Now from this, certainly I can say that minimum value of mod x is 0. Certainly we can say that. Now see what exactly happening when we are solving this mode. If I'm writing this modulus of x, it is something behaving like that. It is x when x is greater than or equal to 0. Now see, again I'm considering the number line. This is your number line. Again I'm plotting the numbers. So the numbers are like this. This is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Now if I ask you what is modulus of 0, that is 0. And certainly when you are writing, say mod of 2 is 2. So whenever if I'm writing a number inside this bracket of this type, so then the value is exactly copy of this. I'm writing copy of this. But now what happen if I'm writing modulus of say minus 2. This is coming out to be, that is 1 unit and 2 unit, that is 2. So what exactly happening? So if I'm writing mod of minus x, it is same as mod of x. In other way around, can we say that mod of x, whenever my x is less than 0, now this quantity, since x is negative, how it will become positive? If you multiply both sides by minus sign, then it will become positive. It is minus x. So now let us do some problem based on this. If somebody say that solve this equation, mod x is equals to 2. So what are the possible values? Now clearly you can see from here, mod of minus 2 is also 2 and mod of 2 is also 2. So certainly the possible values are x equals to plus minus 2. So what we are concluding here, then whenever absolute value is say some positive number, it means you can say that the distance we are interested to find those points whose distance from the origin is exactly 2. So what are those points? You can mark here, this is 2 and this is minus 2. Okay, now if somebody say that solve this mod x plus 3 equals to 0, now it means mod x is equal to minus 3. I think which is absurd. This is not possible. Not possible means this equation has no solution, because certainly there is no real number on the number line whose distance is negative, because distance is a non-negative thing. Now again, suppose my question is mod 3x is equals to 5. So I will write 3x is plus minus 5. So it means x is plus minus 5 over 3. So it is the simplest question, guys. So you can easily solve that. Now suppose my question is solve mod x minus 2 is equals to say 4. So but obvious, we can write mod x, that is x minus 2 must be plus minus 4. So what you will do, one, you take positive sign. When you take positive sign, your value of x is 6. When you take x is equal to negative, so x is equals to minus 2. So these are the possible solution in this case. Now we have another question for you guys. The question is solve this mod of 2 mod x minus 7 is equals to 3. Sometimes what happens, the student afraid of that is seeing that is so many modulus are there. Okay, let us get rid of that. Let 2 times of mod x minus 7 is equal to some t. Now what this question become? Mod t is equal to 3. So again we can write t is equal to plus minus 3. Now what is t? T is 2 mod x minus 7 is plus minus 3. So solving in the two cases, that is 2 mod x minus 7 is either it is equal to 3 and 2 mod x minus 7 is equals to minus 3. Now first of all solve them. So what will I obtain from here? 2 mod x is equals to 10 and my mod x is equals to 5, and from this I can conclude my x is plus minus 5. Now what about this? I can write 2 mod x is equals to, if I shift take this minus 7 on the right hand side, so it will be plus 4. So mod x is equals to 2. So I can say that my x is plus minus 2. So guys, these are some basics I'm solving in front of you. So this type of equation can be solved very easily. Now again, suppose the question is solve mod x over 2x plus 1 is equals to 1 by 3. Now again we'll use the same tactics. On the right hand side the number is positive, so what I will do, x over 2x plus 1 is plus minus 3, plus minus 1 by 3, sorry. So now making two cases, x over 2x plus 1 is 1 by 3 and another is x over 2x plus 1 is minus 1 by 3. Now cross multiply. First let us solve this. So 3x equals to 2x plus 1. So from this I can say that my x is 1. Okay. And now from this I can say that 3x is equals to minus 2x minus 1. So 5x is equals to minus 1. So what is the value of x? X is minus 1 by 5. Now let us do some analytical problems. We have the question for you. The question is, if mod x is equals to some, say 2k minus 4. The question is, find the values of k. Find the values of k if equation has, number 1, two distinct solution. Two distinct solution. Now guys, what do you mean by two distinct solution? That is two different solution. Now see, if I'm writing mod x is equals to 2, so what are its two distinct solution? X is equal to plus minus 2. Now suppose mod x is equals to 0, so I have only one solution. And if I'm writing mod x equals to minus 2, that is no solution. Now I think it is a hint to this corresponding problem. It means it will have two distinct solution if this quantity 2k minus 4 is certainly, that should be greater than 0. So I should say that my 2k is more than 4. So k must be more than 2. Now, if I ask you my second question, exactly one solution. So for exactly one solution, definitely 2k minus 4 has to be 0. So it means your k is 2. And if I ask you no solution, but obvious, the quantity 2k minus 4 should be negative. That is 2k is less than 4, that is k is less than 2. So we have seen all the circumstances when this equation has exactly two solution, one solution and no solution. Now let us consider one more problem of this type. Suppose the question is, if the equation mod of modulus x minus 2 plus k is equals to 4 has four distinct real solutions. Okay, then find the value of k. Find the values of k. Now how we will handle this? Okay, let us try. Since on the right hand side we have positive quantity, if I take this quantity as t, so we have mod t is equals to 4. So it will give either t equal to 4 or t equals to minus 4. Is that okay? Yes. Now substitute t. Mod x minus 2 plus k is equals to 4. And so let us simplify this one first. Mod x minus 2 is equals to 4 minus k. So we have this modulus equation, and now from this we have minus 4. So what we should write? Mod x minus 2 is equals to minus 4 minus k. Now since this equation has four distinct solutions, it means how many solution we'll get from this? The maximum solution that I can get from this is 2, and also maximum solution I can get 2. But how we'll get this? This is possible only if 4 minus k is greater than 0, and I should write minus 4 minus k is also greater than 0. Now what do you mean by and in mathematics? That is intersection, common values. So we'll find the common values of this. So It means from this we can say that k is less than 4. And what should I write here? I should write from this I can say that k is less than minus 4. Now let us find their common values. Now guys, this is minus infinity, this is plus infinity, this is plus 4, this is minus 4. Now the reason for this is this entire region. For this is in this region. So the common values of this, I should say that my k should be less than minus 4. So either you can say that is k must belongs to this interval minus infinity to minus 4 open interval. If you give any values to the k from this interval, then this equation will have 4 distinct solutions. Now see, the question is not difficult. The only thing is that you have to manage the things, that how to handle such type of problems. So guys, this is the end of my first video. So in the second video we'll be doing many more problems related to the modulus. Okay guys, bye, take care.